That doesn't have.
Of course, I need to type, so it's difficult to type and hold the thing at the same time.
Yes.
I guess I have to place it somewhere there, but do not, bother you because it's like that close. I think I'll
Yeah. Nie było w ogóle takiego
Nie,
tego.
tutaj nie. Super słabo. Raz, dwa, trzy, raz, dwa, trzy.
There, but then it's difficult to type. Is here, but here. Speak like this. Okay. Good. Okay. Good morning. It's 9 o'clock already. I think people are still settling in. That's a good time. So I didn't send you something, but maybe it goes without saying you should still install Pixie. That's useful for Pixie tutorials. So if you go to the website, there's many ways to install Pixie. Otherwise, we can do it together. Because in the beginning, I talk a little bit before we do something together. So good morning to a very long conference. Depends if you went to EuroPython already. That's a very long one. This is a URL. You will get a PDF with the material plus some files. And this should bring us to this tutorial. Yeah, so please download this one. You can type it in, or you can scan the code. Should hopefully be the same. It works there. Good. A few words about me. So I've been around this Python for a while, since 1999. Takenovas claims the last millennium. So it's a while ago that I started. I did my PhD at the time, and I did a couple of numerical models. Yesterday I talked about this different coupling yesterday, but always a couple of numerical models. And then so I started with Python, and I already gave some lectures at university, and then was pretty close. And okay, why not also teach Python? And gave my first Python training in October 2004, I think. And out of this, I also founded Python Academy, which is this flyer you see out there in the roll-up. So I teach Python professionally, usually. We do this in person. I have a few other colleagues that also teach. That's why we can offer quite a bit of topics. But I also do this groundwater modeling, so which I talked yesterday, unfortunately, right parallel to Tom Wouters' course talk. So my background is hydrology. And also I organize conferences. So this EuroSciPy started because I started in Leipzig 2008. So I was the main organizer at this time, and also involved in quite a few other conferences. I'm the chair of the Python Software Verband, which is the logo. That's currently, this is the foundation that's officially running this conference, because you need somebody signing the contracts, and that's what it's doing. And I'm also founded a user group. I'm a PSF fellow, and potentially a bunch of other things that I forgot. Good. So that's about me, but this is not about me. This is about the Pixie. So I also have questions about your Python usage. Who has used in Python 1 year or less? Raise your hand. Nobody. Okay, 1 to 3 years. Oh, 3 to 5. Good. 5 to 10. More than 10. Okay, that's a bit. Usually we have a lot of people that started, but this is more like those are more experienced Python users. So we do Pixie. Please download this one. When you download an unzip one, you get a PDF. We quickly go through the PDF. So this PDF, I have to admit, is designed for a 3-hour tutorial. I haven't changed it, so we cannot go through the whole thing, but we still can touch most of the topics. This should be hands-on, but in 90 minutes we cannot do too much, but hopefully you get some idea how Pixie works. So first I talk a little bit, a few minutes, and then we do hands-on things. So if you haven't done yet, please install Pixie. Go to the website. There's maybe 10 different methods how to install Pixie. Choose the one that fits you best. Good. So first, this is the intro with some table of content. You might be aware of dependency management. That's necessary and useful for all kinds of things to do so, and there are different ways of doing it, and it can be pretty complex. So a lot of people worked around. I still remember the times where dependency management was downloading a zip file, unzipping it, and then copying things somewhere and praying that things work. And then things came around. Anybody still knows the cheese shop? So the name of PyPI before it was named PyPI was cheese shop. After so one of the things, and then they gave it a more serious name and called it Cheese Shop, as a Monty Python Flying Circus sketch. So, and then it's pretty complex, and there's many different ways of doing it. If you use Linux, then you use one of those Linux systems to set it up, Yum or apt-get or all kind of these things that work. And I wrote it a little bit. And let's look at the ecosystem. It's worthwhile to explore a little bit. In Python, you have two different main strategies, going with PyPI or with Conda, and here as use Conda Forge. So the name Anaconda can be pretty confusing because it means at least three things. It's the name of a company, which used to be had a different name before. It's a name of a distribution, not unlike Linux distribution, and it's a name of a repository where Conda Forge is one channel in. So Conda Forge is hosted on anaconda.org, which is a repository. And the distribution, they changed the license back and forth, so you had to pay money for it if you have a bigger institution, which led to a lot of confusion. I got a lot of questions about if they say Conda, they say we cannot use it because of license, which is only partially true. It's like similar to when you use Red Hat, you have to pay. If you use Fedora, you don't. So kind of similar to this. So most of the thing what we do now is Conda Forge. We see Pixie will default to Conda Forge, which is the most prevalent channel. Yeah, it has advantage in Conda Forge. Everything it kind of fits together. So the likelihood that packages agree with each other is much higher if you install them all from Conda Forge. Prime example is GIS, Graphic Information System. They use something called GDAL. And as I remember not so long ago, the standard GDAL, when you install it, this is standard Python from python.org. You can install it with pip, and then you run it, and then Python segfaults because they use a different DLL down the way somewhere. So a dependency of the dependency of the dependency that has nothing to do with Python whatsoever. They don't like each other. When you do it from Conda Forge, then everything should fit together. Good. So we have all kinds of things. And the big advantage of this Conda Forge is you're not restricted to Python. They also offer R packages and other packages. So I do install Git, GCC, Pandoc, Rust, types, FFmpeg, and all these things from Conda Forge. So everything I can get from there, I will install, and I don't have to rely on Homebrew on this machine or any other system. The only thing that I still need, it's LaTeX, but I think so far it's the only one. So post LaTeX is pretty big. Maybe it will be there sometime. Good. So there are many tools. So this is a partial list of tools that fly around at this thing. They haven't used all of them. I have a disclaimer. Many of these fly around. So last year at EuroPython, last week at EuroPython, I gave a UV tutorial. So UV is a big player. If anybody wants, I can tell a little bit more the difference between you and Pixie, and they're all around. Yeah. So Mamba is just a different name for Conda, so to speak. So it's supposed to be 100% compatible. It's just faster, and all the others, they belong into the pip universe. They're all pip universe kind of things. These tools, they have slight different purposes. Yeah. So usually UV and Pixie are the ones that compromise the whole ecosystem, the whole functionality. These other ones are sometimes specialized. No? Good. So, and what we do, the tasks are installing. So if we have different tasks, if you're a user, you're a consumer of software, you do something, you want to install things, and you have environments, but also package development. So if you want to develop a package, so we have a PyProject terminal and want to release something, and also you have Python version management, because as well as UV and Pixie support global things. So we will look at the differences between the approaches of if you use Conda directly or Pixie, the approach is slightly different how things go and how things are arranged, but the global setup of Pixie can be also interesting. Good. So, and I put it in a table. You see, there's a big table, and I put some crosses and hooks in here. So, what they support, what they do, and how they work. But of course, Pixie got all the stars. What else? So then this one is going to fit pretty much everything. But can do a few things. Yeah. Okay. So that's one that the names didn't fit in here, so I wrote them down here because otherwise the table would be too wide. Yeah, and which one is useful for packaging? So some of them can package. So pip cannot package, for instance, cannot work with Conda Forge. So when you start with Conda, in Conda environment, you can always, to some degree, include PyPI packages, but not the other way around. That's why I switched to Conda pretty early, because I can always include PyPI packages, but you cannot do it the other way around. Good. So Pixie supports both to some degree. So with Conda, you can also to some degree use PyPI packages. Pixie takes it a notch further. It's not fully integrated yet, but there are some developments that go there. So the PyCon ES took part in the sprint. They call it Conda PyPI, which is a new project that tries to make Conda more compatible to PyPI packages. And the Conda folks and the Pixie folks collaborate on different levels, and they work together. And I think now the new Conda is actually using the Pixie solver internally, or you can actually turn it on and things like this. So they kind of work together. That's why these things. Oh, let's go. Let's go to the Pixie basics. Let's. I need to type a little bit. So, can you hear me? Yes. That will be difficult because I need to talk like this and type. And I do have. Yeah, but it's for the recording. I think it's recorded. And that's why I need to do it. If you see how it goes. So now let's do some hands-on stuff. So when you install Pixie, then you type Pixie, you should see a command Pixie, and then do a little bit. So I do everything in. Yeah, so if I hope I don't type it over, so I need to sit here hunched. Okay, so am I in the right directory? Yeah, so I'm in the right directory. Maybe a little bit bigger. So when you type Pixie help, then you get a pretty long list of all these things. Yeah, so I'm not sure if I keep it like this or if I make it dark mode, because when I'm in the terminal, I can also change it to dark mode. Dark mode, high contrast. Is this better? Maybe not. So can we back? So I think at PyCon, at EuroPython, we also went to the light mode. Probably that's easier to read. So you have a lot of commands. We're not going to show all of them. We use a few of them, and we'll go through some of them and work. I just learned yesterday that Pixie Publish is now a thing, and this Pixie build, which I use, it's not there anymore. But yeah, things are changing pretty quick. So I had the folks from pre-dev looking over the tutorial, and they said it's okay. So I didn't do anything stupid here, and should be up to date. But this was in April, and now it's July, so it might be up to date. So the first thing I would, since you installed Pixie, you have the newest version of Pixie, and I might not have the newest version of Pixie, and I can say Pixie self-update, and then it self-updates. Yeah, and now from 72 to 73, it will be updated, and it gives me a short description what's going on, and I hope the internet is playing with me. So it's always good. Yes, you have to install it first. So you go to the Pixie Python. No, it's written in Rust. It's a standalone. Like UV and Pixie both are written in Rust. So if you go there, that you find a getting started, and then there's this installation thing. So you have many different ways of installing it. This would be the easiest one, depending on your operating system. Yeah, there's one for Windows. You can have a installer, and you have this one. You can use it wget, and there's other potentially methods to do this. The usage is the same, and it should be totally operating agnostic. Only the installation method is different because you have to. Once you install it, you have Pixie, and everything should be exactly the same. They even come with their own shell. If you saw the talk yesterday, so you get shell commands that you can use inside your tasks. Then those typical bash-like commands would work in Windows, even though you don't have anything installed in Windows. That it's you can install Git, you get a lot of the commands, but if you don't have it, you have these things. So that's what I did self-update now. So once you have Pixie, it shouldn't be that big. It's written in Rust, so it's a executable which is comparatively small. I don't know how big it is, but usually it goes very quickly. Yeah.
After you use this script, then how do you get the command to the...
You type Pixie and it should be there. Otherwise, you might need to start a new shell. So if it doesn't come up, because it has to pick up the path. So when you install it, it modifies your path variable typically, and you might need to make a new shell or source your. But you just use the shell as
Yeah, small announcement. If you have a question, local organizers would appreciate if you go by microphone, so I will approach you. So just to have it on recording, okay?
So, okay, I just open this here, so I have my document here, so we go through. Pixie. So everybody got a rocking Pixie? Yeah, good. So, we will see Pixie we mainly works with CLI, so we type something in here, but you can pretty much do most of the things also modifying a TOML file. If you know PyProject TOML, you probably kind of somewhat familiar with the TOML format. So TOML format looks a little bit like the INI format, but it can do more. It's been around for a while, and it's also, I think it comes from the it's used in Rust quite a bit. So it's not strictly connected with Rust, but the Rust people use TOML format quite a bit. So there's maybe also a reason that's used here. So I make a directory here, so we can go there. I'll just make a projects directory, projects. Yeah, and I change to projects. So I would also recommend to you to go to projects. And now we have an empty directory. And now we do a few things. When you work with Pixie, Pixie is usually designed for projects. So you want to work with a project, and then Pixie will generate a new project directory for you and puts a .pixie subdirectory in there with all the information. That's the main usage. There's also other usage. You can use Pixie Global, which you use global commands that go into your home directory. So I use Pixie Global quite a bit. But the main usage is project-based. This is different than Conda. Conda typically has a central place where you put a Conda environment. You have to activate the Conda environment. And very often you forget which environment you need to activate for which project. Yeah, you have to write it down somewhere. And here it's different. Everything is in the .pixie directory. And most of the time when you work from this directory, Pixie will pick up this environment. Yeah. You can also use this environment from somewhere else. There are different ways of doing it. The command we use is Pixie shell, or even nicer, shell hook, to create a shell hook command. So let's create a very simple project. There's a Pixie init, and this Pixie init offers, again, if you look at the help, you get a long help of stuff. Yeah, so Pixie init, you have a lot of options in the path, and this path will be new directory with your project. So everything goes by directory, and everything in this directory belongs to .pixie. Similar to Git, when you're somewhere, Git will pick up where the Git is located and work with it. Git supports nesting. Pixie doesn't like nesting. So I had the very problem because I used Pixie to start my Jupyter lab, and then if you want to show about Pixie, I get a warning that I use Pixie inside the Pixie because they say, okay, I'm using this configuration or the other one. That's why you might see I started the Jupyter with UV just to get rid of this one in this case. So that's a good usage for it. You can specify a lot of things. You have the concept of a channel. So if you work with Conda, you know the channel. So the default channel is always Conda Forge. we will see in a minute. You can configure it in the TOML also. You can use all kind of other channels. If you want to use a default channel or your own channel, so I have some stuff in my own channel, you can have the channel. And a few other things which typically default platform is the current platform and so on. You can do all kind of stuff here. Most of very rarely you need it. And instead of putting it on the command line, in the beginning it makes sense, but once you have a TOML, I prefer usually to put in the TOML because it's easier than have it the command line. So the init command has also two options. You can you have the format. So you can go with a pixie.toml or you can use a PyProject.toml, and they even support Mojo project. So Mojo is a Python-inspired programming language, I think. So it depends what you want to do. So if you have a project where you want to try something out and you're not developing your own thing, you don't have a PyProject.toml, then use a pixie.toml. If you have a PyProject.toml, you can decide, put it in the PyProject.toml or put a pixie.toml at the side. Both approaches are okay. They can have different implications. So if your colleagues don't use Pixie, I would make an extra file, and you might not even push the Pixie.toml to GitHub or wherever you push, and people don't see it. Otherwise, everything's the same. If you use a PyProject.toml, you have to write tool.pixie, like tool.rough, tool.things, if you're familiar with this. Okay, so let's create a project. My project, what a great name. So you do this init, and per default, you get, now it creates this directory. Yeah, and if I cd in this directory, my project, you get this pixie.toml. So if I can do this here, I can open the pixie.toml, my projects here, and then I have my project. Great. And then you have this toml, and it looks like this. So it finds my name and email address from Git configuration. It gives it a name. It uses a platform. So Pixie supports multi-platform development. So it takes the platform. I'm on Mac M1. That's why it chooses this one. But I can also put in Win32 and Linux on this machine, and this would create a log file, something we'll later on, that would work on Windows and Linux. So it would use a version of a library that would work on Mac, Windows, and Linux. And I never seen a Windows system, but I know my project works on a Windows system, which is a big improvement in pip, because pip you have to run to my Windows machine and try it out. It works on my Windows machine, and then I have to manually fix the versions to make it work. Here it does it like this. It adds a version. We'll look at tasks later on, and there are no dependencies yet, so you can list dependencies. So if you do the same thing in PyProject.toml, it would look the same, but you would write pixie tools.pixie.dependencies. Yeah. So if you have a PyProject.toml, you have the normal dependencies, and you have Pixie dependencies. You still might need to repeat something there, because sometimes the names of packages are slightly different in PyPI and Conda. Usually they're the same, but sometimes they can be different. And the Pixie project also, they have a name mapping and so on. They have a few things that make things easier. So you can work with these things. So that's how it looks like. And now we have our project, and our project looks like this. And now we can add dependencies. And I do this again from the terminal. And you have this pixie add command. This is pretty what I use most of the time, pixie add. And I can add a dependency. Yeah. And I can say pixie add pandas. So I didn't add Python yet, it's there, but I didn't specify the version. Usually it takes the latest version. You can also do this. I will say pixie add pandas, and then it will add pandas. So it's very fast because it's cached. So Pixie caches, and since I installed pandas before, I saw pandas a lot, the latest version is there. If you haven't installed pandas in this version for this Python version and this pandas, the latest Python pandas version, it will take a while to download. Usually it's very fast. So Pixie is really, really super fast. It's even faster than Mamba. One is, it's written in Rust, so the programming part is fast, and the other one, they do very aggressive caching. So there's a cache somewhere. There's also a cache command. You can clean the cache. You can work with the cache, but most of the time it works because it makes things faster. So typically it chooses the highest version it can find, which is obviously 3.03, and then it limits it to the next higher version. If you work with a 0 version, it's a bit strange because if you have 0.12, it limits it to less than 0.13. You might want to adjust this one. So what happens? So I need to close this file. What happens? It modified the Pixie TOM. So everything adds up here. So instead of you saying Pixie add, I could have written it there. That means it might not be installed. Yeah, so sometimes it's installed, sometimes it's not. You can always force it to install. So UV, this command is sync here. You say install. I think it's pretty much the same thing. And if it's not installed, it will do it. Otherwise, it will take a while. When you start your program the first time, it might take a few seconds until things happen because it's doing the installation. And it's kind of lazy to this degree, which is okay. The thing is, if you go somewhere where you don't have internet, you might want to make sure everything runs before you use it. Otherwise, it tries to download something which doesn't work if you don't have internet. So that's usually how it works. You have the dependencies. Yeah, question? Do you need your microphone?
So I noticed the constraint of pandas less than version 4 assumes semantic versioning. What's with packages that use calendar versioning, for example?
I don't know, but I think they will figure this out to use some calendar versioning. I'm not sure how what constraint they put. So this is just a suggestion. You can always change this. They have some default, but you don't have to. If you just put a star, it takes the very newest version all the time. So I haven't used calendar versioning yet. I don't remember, but there will be some scheme, and you don't have to keep this. You say add, and then you go in the file and edit the file, and you can do whatever you like. Yeah, so it's typically a good suggestion, but it's not required to keep it. Good. So that's what you have, and you can also, if you want, you have a Python version. So per default, it takes the newest Python version, but I could also add. So if you want to go to the older Python version, then you can add a Python version. You can also say the same thing, add Python, and you can specify the version. So if I specify the version, so if I want to go back to 3.13, I say 3.13, which changes things and takes a bit because now it needs to downgrade my Python. And you might also end up with a different Pandas version, but I think Pandas will be supplied for 3.13. So it takes a bit. Well, maybe. Yeah. So, and I will update things. So, yeah. Added Python 3.13, which now the thing looks like this. If you open it again, then it puts 3.13 here. And per default, it does something like this. If you don't specify Python, it's Python's a dependency of Pandas. It will take the latest Python implicitly, but you can make it explicit by putting Python there. Yeah.
So once you run this command, it also created a file that was pixie.log, and it had lots of file names. So I'm wondering, when you did that, did it actually download all of those things that are listed there?
Yes. Yeah. Yes and no, because I have a cache. So for me, it might be faster because a lot of things I installed before. And if it just goes to the internet and checks the metadata, and then it looks, do I have them already in the cache? So they have hash, all the files are hashed. They know exactly, we have this file already. I don't need to re-download it. If I would clean my cache, things would be much slower potentially.
Okay, thank you.
And this log file is here to make it reproducible. You see, this log file is only for OS ARM. If you put in Win32, it will create a log file for Win or Win64, it's called. Yeah. So there's one of the commands gives you a long list of the operating system support. Is maybe 40 whatever architectures, operating system, all kind of combinations, and you can create a log file for all of them. So that's very nice because I can now say, okay, I want my package to run in this operating systems and this Python versions, and it goes to counterfortune checks, are these libraries available in this combination, and resolves everything. Without it doesn't make sense to install Windows packages here for sure, yeah, but it still resolves it, and it should work on Windows, and it does work on Windows because those packages are in counterforge, unless the package itself is corrupted and doesn't work, but it's not a question of Pixie, yeah. But if the package is there and it's a valid Windows package, you can install it. So that's very nice. So you can do cross-platform development without having a Windows machine, a Mac machine, and a Linux machine sitting somewhere. And maybe if somebody is up for FreeBSD or so, I don't know if it's different than Linux, but to some degree it might be different. Yeah. So And this is a log file with everything in here. This log file is, from this log file, you can recreate things. Unfortunately, these log files are slightly different. Now there's a PEP for a year or so that specifies how a log file is supposed to look like. The UV log file looks slightly different, and the PXE file looks slightly different because they do have some different information in there, which the PEP doesn't have. I don't know why the PEP is different than this kind of de facto standards are out there. I haven't investigated this yet, but it's slightly log file. Usually, UV allows exporting the. Probably PXE also converting this log file to a standard log file. Maybe they have it now. I haven't looked at it yet if they have it. So the log file is important because you have everything there. Otherwise, you never ever modify the log file. The log file is auto-generated. So don't modify it. Yeah, you should version control it. Yeah, when I update something, we always when I change the TOML, the log file changes. Check both of them in at the same time with the same commit because they kind of one unit. That's how I do it. Yeah, but you can always go back with a log file to an earlier version. Good, that's how it works. And you have this log files, and also it puts a Git attribute here. Yeah, so it adds something there that makes Git work together with the log file in a sensible manner. Yeah, whatever this is, and also has a Git ignore, and it puts a few things here to ignore the .pixie, because the .pixie contains everything that you have in Pixie. That's interesting just for you to look inside, and you see you have your environments, which is a default. So inside the Pixie, you can have multiple environments. We will look at this. It can make sense. So you have a testing environment, a documentation environment, whatever. For each different task, you can have a different environment with different dependencies that can be independent or dependent. The other both is possible. Yeah, and per default, it creates a default here. And then you have all kinds of stuff in there, and that might look familiar. So you have your bins and executables that are there. So since I use Python 3.13, looks like this. And then you have this the lib. And then lib, you have the 13. And then you have side packages, and here you have your pandas. That looks just like Condas doing pretty much the same thing. Yeah. So we have this one. If you delete this .pixie thing, no problem. Pixie will recreate it next time you install it. Yeah. Sometimes you have to do it. So if you do a lot of adding and removing, you might add up with some strange behavior. Deleting the .pixie and reinstalling typically straightens things out. That's my experience. Yeah. So yeah, these things are in here, and you see Pandas has dependency in NumPy and datutil, obviously, and installs it there. Yeah. So there's no OpenPixel yet. So if you want to use Excel files, or OpenPXL, and then you have to install this also, and that would add up there. So because Pandas has some kind of optional dependencies. Yeah, question?
So yeah, I have a question on like how you define the environment, because you're showing here like an interactive way. You decide, oh, I want this package, you add it, and then the YAML gets updated. Yeah. Is it maybe better practice, or I don't know if that's practice, but I'm assuming like if you were to just write the YAML by hand, you could you copy this YAML in a different directory and say install, and then sit. So this CLI is just a way to edit the YAML essentially. So I think you can achieve everything you can to the CLI by hand editing the YAML file, the TOML file. Sorry, the TOML file. So I guess let's say you already have the TOML file. How would you install that environment?
I make a new environment, copy the TOML over, and say install, and that's it.
Maybe you could show that. That would be that might be nice actually, because that's how I define my environments. I usually write things by hand, and then I go like, please resolve everything in one go.
So I'd say take this one, copy, make a new directory. Yeah, and then I go here and paste this in, and let's make a new terminal, and this terminal. I have to go up one, and I go to my project 2. No? Double. No. I'm amateur. Yeah, because I'm always in the one I'm there. Right. So okay. And now I say a Pixie install, and I should create this one. So I might want to rename it, because now it still has a name, and I would call it my project 2, which is nicer, because if I activate it, it will show up the name in the in the command line, we can do this in a minute. The pixie install should do the installation, and it will take a little bit. Yeah, see now it's doing this. Done. Yeah. So now how to run it? I can say pixie run. So if I want to do anything, I always have to say pixie run. Python. Yeah, and that should be a 3.13, the latest 3.13, which it is. Yeah. So if I want to know with pixie, I say pixie run which. So this is now operating system specific command to find out what Python executable is using. You see it's using so long. Yeah. Gives me the full path where things are installed, and it's a .pixie environment. It comes from default. If I say there might be other Pythons in my path somewhere, which are there some other Pythons that are in here. You see there's a pixie env conda. Of course, I installed conda with pixie. Okay, yeah. So that's what I did. That's why it's there in a bunch of some library paths somewhere. I think this is an artifact of UV because UV creates these temporary directories. Yeah, so it's always a good idea to check what Python are around, which Python are using. Because sometimes things work until you realize you use a different environment or Python version or something, and then something is different, and it might take a long time to figure this out. So this is good. You can always use pixie run. Alternatively, you can activate it, and there are two ways of doing it. You can say pixie shell, which changes the shell, or alternatively, you can create a shell hook, which might be nicer. So because the shell actually starts a new shell, and we can do this. I say pixie shell without the hook, you see, and then it takes a little bit because now it starts a new shell and renames everything to the project name, which is important. Now you see the project name, and you have a new shell. And now if I say Python version, yeah, then everything is set. I don't have to say pixie run. So everything, all the commands now are implicitly pixie run. Yeah, that's the way to work. Usually I activate the shell. Now you can also change the directory. So now you don't have to stay in this directory. When you say pixie run, it depends where you are because it checks for the pixie toml configuration stuff in the directory. Once I activate it, now I can change directories and still okay. So one alternative is if I say exit, I exit the shell because it's the first shell. The other one would be pixie shell hook. Pixie shell shell hook, yeah, and this one spits out and started out a lot of stuff, a lot of environmental variables, and usually you redirect it into a file, and you can call it anything, but shell hook is a good name for it. And when you do so, then you can look here and it creates this shell hook. Where is it? There it is. It takes a little bit, yeah, and you get something like this. So it exports a bunch of environmental variables. You don't have to know what it all is, yeah, but there's a bunch of specific conda and shell. All these things are used by Pixie to do something, yeah. So these are environmental variables, and it does a bunch of stuff. This will look different in a different operating system for sure, but here it looks like this. And now I can source this one, which is faster. I can source the shell hook, which is much faster. It has the same effect as doing this. Now, if I type exit, I exit my shell. I don't create a new shell, and there's no real way to undo this change anymore. But you just make a new, close the shell, make a new one. I don't think it's a big problem. Now we can also change the directory and do it somewhere else. In fact, I created my own conda-like global thing just with this thing. It's very easy. I have one directory, I put all my global ones, and then I activate them, and I have a command called pact, which Pixie activates. Yeah.
One question here. So I see that you are doing this from already a conda environment, and the conda environment might define environment variables that some packages use and some do not. For example, if you install Clang, it will set compiler flags, and those will be in your base conda environment. So
this is because I still have a bunch of conda packages. I haven't transferred to Pixie yet. That's a historical thing. That it says base is just because I'm using the base conda. But it will override them here. It will override them just in the shell. If I close the shell, everything's back to to what I had before.
But do those environment variables that you have in the base environment still affect the PXE environment in this case?
Yes. Yeah, but these are the standard ones that don't do anything special. But I can turn them
Okay,
off.
thank you.
Yeah, they would be there, but as you can see, PXE defines their own and overrides the one that is interested in. Yeah.
Sorry, Mike. Quick question. At which point did we add Conda? Maybe my head was sleepy.
We didn't add Conda at all.
It's always
I do have Conda installed for historical reasons. That's all. So I have Conda, Mini Conda, Conda Forge, Mamba, all kind of stuff. Because I went to all these things and I still have environments that still work and haven't changed them yet.
I see you've got M's Conda. So where did the Conda come from? Like
Panda?
Users Mike.pixie M's Conda.
When you were searching for the Python.
When did we add Conda?
We did not.
He was searching for all Pythons on his machine.
Yeah. So, yeah, this I just do the which is a Unix command. Show me all everything on my path that reacts to Python and shows me all these things.
Okay, thanks.
And these ones here, this is global. So I installed Conda with PXE because before I used Conda build to build something, and I didn't want to touch my standard Conda, which I use everything, and I installed the new, but I need a new Conda. So just the question: this old Conda still runs with Python 3.11. Do you want to change everything? Yeah. Yuck, shaving. No, I didn't want to, so I made something new. And that's why this one, this PXE, this .pxe envs it's a global. We come to this. If I say PXE, okay, PXE global dot list or PXE global list. That shows me everything I have installed globally. So PXE or Conda Forge in general is not restricted to Python, and you can install all kind of command line tools or other programs. It doesn't have to be command line tool. You see, that's all I installed. I installed UV with PXE just for. Yeah. So see, and that's everything I installed. You see, there's quite a bit. These are all my ones. Like H is we can encrypt things. It's a Go program, for instance. Yeah, Binstar is a Conda thing to now you can use PXE publish, but before I used Binstar to upload to anaconda.org. And so there's many of btop. It's a Unix command to show you things. CMake. I installed everything with. I installed Conda itself, and that's why it shows Conda. Yeah. So Cookie Cutter is a plain Python package, so you can install places, but this one only works for commands that have a CLI, so that you can type on the command. Like pure library doesn't work. You can also now if I want to install some X with Cookie Cutter, I can say edit. There's a with command, and I can say to this global environment add another dependency. If you look at the operating system, this .venv for each package is their own Conda environment. They're all isolated. They have nothing to do with each other, so they don't influence each other. It's not like a global thing. And if I install something global, all of a sudden nothing works anymore. It's like my experience with Homebrew. You have these things like DOS to Unix. If you have to exchange that files with DOS, you want to take care of the line endings, those kind of stuff. Yeah, FFmpeg. If you want to stitch together PNGs to make animation, I use FNpeg and so on. GitHub as a command line thing. Git itself, you see, I have a lot of Git and a lot of Git extras, and this one exposes all these commands. All these commands come directly from there. Yes, we have a section about the globals. So you can always add your new global, and everything works that you have in Conda. So per default, the channel is Conda Forge. Yeah. Here you can list your own channels if you like. So typically I list my own channel first because this order has channel priority. There's also some options if you say you want to have a strict channel order or not or something. There are some options here. I need to read up that some combinations, but usually the channel order is important. Yeah. So if you say this one will never ever take anything from default, which is important now because default has a different license scheme. Yeah. So if your company more than 200 people, I think they changed this. Conda is going some changes. There will be some changes to this thing to some degree. but license can be complicated. So if you don't want any default, you don't need the default. It never goes to default, it's not there. But you can have different, like if you want to have a different NumPy version, there are quite a few entities out that have their own NumPy. Yeah? For instance, NumPy has by default has 32 dimensions. If you can have more dimensions, but you need to compile NumPy yourself. So you can make your own NumPy distribution with your own channel if you really want to. So we need more than 32 dimensions for whatever reason. There are people out there that need this. Astronomy, they need this, for instance. And then you can make your own NumPy, putting in your own channel. And if you put your own channel before ContraForge, it takes your NumPy. You still have to make sure it works together with all the other, with pandas and so on. Yeah, because if you don't compile your own pandas, you have to make sure this NumPy works with this pandas. That's your problem then. Yeah? I have no idea how to do it. But if you want to, you can dive in there. Yeah. So channels are important to do something. They changed this one. So this workspace is a new, before it used to be called project. And I still have a few old project, and it says, okay, you're using an old TOML, please rename project to workspace. So they sometimes update something, but most of the time when they update something, they give you some warning and they give you some message how to update things. Okay, use this one, use the old log file format, update by using this command, and then you update it in the log file format. That's usually recommended. That's what I do. Yeah, that happens from time to time. They're going fast. As you now, they are 0.73. They're still at 0, that they can still change things pretty quickly. But the releases are very, very frequent. So tomorrow you might have 0.731 or something. So it's pretty easy. Good. So now you can add these packages. So now we are not restricted to conda packages. We can add PyPI packages, which is possible. So sometimes you go there and there's a package that only exists in PyPI. Yeah. ContraForge has 33,000 packages or so. PyPI had 850,000. So yeah, there's more. PyPI has a lot of dead packages that you cannot use anymore. But still, you have a few 100,000 that are really usable. And a lot of small things only exist in PyPI. You can use, there's a conda skeleton or something. You can make a conda package semi-automatically from a PyPI package, but this is quite a bit challenge to do so if you want to. But you can install PyPI packages here. And to do so, you have to specify the channel. Let's go to the terminal. And now we can say pixie add, see, pixie add, and I add something. Now I specified the channel and say PyPI, you see, and not this shell remembers what I did before, but I don't want to install this. Let's say I want to read the docs action for some reason. This read the doc action is something that's not on. So if you use things and you move it up to read the docs, you might want to have this one. And as far as I know, at least when I tried, it's not available in ContraForge. Maybe it's now, but you can still use PyPI as for an example. So I always try to use conda packages first.
One question here. So what happens if the package that you want to pull from PyPI is a source package, not binary, and you need to compile it?
Yeah, this one uses UV in the background, and UV is a drop-in replacement for pip. So it does essentially the same, as conceptually the same as pip. So it would do the same thing. And if the thing gives you a source thing and it says, okay, now here you need GCC to compile it, will do this. Yeah. So that's why I would always use conda packages first. Conda packages are only binary; they're always compiled. There's no such thing as a source package. Yeah.
But in this case, could you, for example, tell the Pix environment with the compiler that you want to use to build and environment variables and similar, if you want to build something from source in this case?
Yeah, so if from source, then you might read up how to do it, and you might need to set some environment variables and tell them use this GCC version, use G-Fortran if you're lucky enough to have Fortran inside, something like this. That has nothing to do with Pixie, because Pixie just invokes UV, and UV is doing the PyPI thing, and then they install it from PyPI. Hopefully you have a wheel, then it's it. If not, actually the same happens.
But in this case, you would need to install one before the other if you need to set compilers, for example.
Yeah, so that's all. That's that's PyPI thing. It's up to you. So if something like this happens, then you need to read, say, okay, you need to install this and this first because you need the compiler, you need to set the flags, you need to do this, you need to do this, and it works only on Tuesdays. Otherwise, so those kind of things. Yeah.
But is that controllable in this TOML file, for example? Like that some package needs to be installed before the other?
Actually, this figured this out. This one goes in there. If this is specified in dependencies, it will. So this is a small problem. If this RTDS action thing would have a dependency, it would install it from PyPI, even though the dependency is available from Conda. These loops are not interleaved. These are two different things. If I say PyPI, it only goes to PyPI and Conda is out. The new developments will change this, but to my knowledge, currently, that's not the standard one, doesn't allow this. So once you say PyPI, everything comes from PyPI. So if the one would depend on NumPy and I haven't installed NumPy, it would take NumPy from PyPI. If I install NumPy before with from Conda Forge, then it wouldn't, because you have NumPy already, you don't do this. That's usually my approach. So I check what are the dependencies of this package, and then I need to list all these manually as my dependencies. And then they would come from Conda Forge first, and then later on I say install this from PyPI. That's not perfect, but kind of works. And I think Wolf and they are very aware of this, and they will solve this problem. It's not easy to solve. And I think Conda PyPI is doing exactly this. So we have the priority of the Conda packages, and only what's not available will be taken from PyPI. Now do it semi-manually by looking at what the dependencies are and installing them first from Conda Forge whenever possible. Yeah, that's always a problem, combining these things. And yeah, but I think the story gets better. Because now at least Pixie knows that is from PyPI. You could also Conda also supported PyPI as a channel to some degree, but the integration was not that great yet. Good. So now we have this PyPI ones, and you can have this, and then you can have environments. So we can have features and environments, and to do so, you need to put in features environment, and that's a bit tricky. So I had this because you have two CLIs, and then when you say I want to add a feature, say there's no environment, and then there's no feature, so they have this little bit back and forth. But I have an example already, so I don't want it. You can always edit things. So if I go up here and you go my projects or Pixie projects, the first one, which I gave you already, and you have a Pixie TOML, and there's a bunch of stuff in there that we already installed, and now I have a feature and an environment. So features are small pieces you can put together. Environment can have multiple features. In this case, I only have one feature. So this is typically the default. You always do it like this. And this is the test. And you see, I have a list of features. Here I could add more features. Yeah. So we can do another feature, doc, to create docs with things. And we have another feature doing something else, and then we can combine it to a multi-feature that says dev, and dev wants to have everything, depends on everything. We just list them. Yeah, and then you have this environment that would this. And this one, solve group default. So this feature test will install PyTest in addition to everything that's up there. If I say solve group test itself, then it would install only PyTest without anything. But usually not useful, because you want to test your stuff, and your library is depending on these things. So you can have features and environments. It took me a while to figure out, because all the examples I saw, this is always a one-to-one correspondence. So why do you need two? But you can have multiple features that are grouped in one environment. Yeah, and that is useful, because once you have this one, then you can have you can run things in an environment, and you can isolate it. So if people want to work with you and they never run tests for some reason, they don't have to install PyTest because they don't use this environment. Or they never build the documentation, then they don't have to install things or mkdocs or whatever you use, and so on, if you put it in environments. Yeah. Yesterday, the Pixie talk, remember SciPy? They showed 50 environments for all operating system, because if you can make environment for FreeBSD, and most people never ever touch FreeBSD, they don't have to, they're not concerned with it, totally isolated. Yeah, and each environment essentially is their own Python installation. It's their own thing. So if I just copy this over to my file now, because I'm too lazy to type this easiest one, I take this one and copy it over this Pixie here and just put it in. And then if I do this, so the problem is I changed it in between and I didn't update, so hopefully I can survive this one. So now, since I put this one and now I put it, now I save it. Yeah, so this doesn't refresh the thing. So usually I use Visual Studio Code, but here I have everything together in one. That's usually a bit nicer for teaching. So if I have this now, now I can say Pixie install, and Pixie install would now do a few things and install these things. Pixie install, and now it would take a while and installs the default environment, and should also install. Am I in the right directory? Less. Okay, less. Double S. Yeah, so because I haven't used this environment yet, that's why it's not there. So if I want to install the test, I have to say Pixie install environment. Yeah, dash environment E, and I say environment test, and then it should install the test environment, which it does, and I'll install PyTest. Yeah, and now if I say which PyTest uses why doesn't work. That's not what I wanted. PyTest should be installed. Yes, I have to say Pixie. This one is a default environment and not the test environment. To do so, I need to say Pixie run. Oh. I would need to use a shell hook for this. Okay, I can make easiest one. I make a new directory and show you how you can, because you can activate. So you can either say Pixie run. That's a good thing. Pixie run, and this Pixie run you can specify the environment. So Pixie run supports a lot of things, and one of the flags of the many flags here, it's environment. You can specify the environment. Per default, it always takes a default. If it doesn't say nothing, it takes a default. That's why it didn't work. But I can say -e test, e test, and then I can say which PyTest, and hopefully now this works. And it tells you now it's using, yeah, now it's using this PyTest, not the default one. Yes, exactly. That's what you can activate. You can say shell. You can have again shell activate. That's what I want to show next. Or you can make this hook thing, the same thing. But you can say Pixie Pixie shell, and this shell also takes a e test, and then it does a test. Yeah. So usually the switches are usually the same. Now you see, saying it's my project, but in this kind of, you want to have sub environment test, and you have the test activated. Yeah. So that's very useful. Now everything you do, it's done in the test environment. So you can have multiple environments in one Pixie file, and that's useful. And don't be concerned about the usage. So first thing, Pixie is caching and symboling things. It doesn't copy things around too much. Yeah. And also here I make it dependent on. See, I say this one depends on default, so it reuses them from default. So everything is available here without, and they have smart strategies. They don't copy files around unnecessarily. Depends a little bit on your operating system. So Windows might be a bit different, but the worst thing happens, you pay space on your hard drive. And space on hard drive is much cheaper compared to other problems you can have. So we talk about 2 megabytes. Yeah, question?
I have PyTest already pre-installed, so if I'm now on the default environment.
Yeah.
I have PyTest already pre-installed, so if I'm now in the default environment and I use Pixie run which PyTest, then it uses the pre-installed PyTest, and it does not tell me in your environment I do not have PyTest.
You have to say Pixie run -e.
Exactly, that's what I did. I mean, I did it without the E.
Yeah. And if you say, of course, I also have multiple PyTests installed. What did I do?
No, I
not
mean,
Pixie, not shell, not no shell. Pixie run. Well, actually, I'm already activated. I just say Pixie. You see, I have multiple PyTests installed.
Yeah, but if I'm in the default environment, I would expect I don't have a PyTest, right?
No. Because PyTest is just it's a command that you look for if it's on the path. If you say which-a PyTest, you will find all your PyTest, and Pixie will use the external PyTest. If you don't have it installed, it will use external, just like Conda, same thing. So you can install your own PyTest in Pixie, which will be first in your path, so it will be used. If you don't have it, it will take whatever PyTest it finds next in the path.
Okay, thanks.
Yeah. So the brute force one, you should use a full path, and then you are out. But that's usually not good. Yeah. So that's usually how it works. So it's a partial isolation. So you isolate it, but if a command exists outside, it will find it. It's not a Docker container. It doesn't work, but you still takes the system commands. So that can be tricky. That's why this which A is usually good to know what kind of executable am I using. Do I want to restrict it in some other ways? Whatever. So most of the things work with environmental variables. All this stuff is set with environmental variables. So you can check the environmental variables that start with standard Pixie, and some of them the standard with conda underscore, not under Pixie, and these determine this one. And the documentation is a long list of all the environmental variables. I don't know all of them by heart for sure, but they are there and they mean something. And then you can turn all this, change all this, what's displayed here. These are environmental variables that make this look like this. Yeah. So now let's inspect it a little bit. So I can say Pixie list, which is important. What do I have? So this is very important. So, and you say Pixie list, and you get everything installed. You see, there's a bunch of stuff installed. You see, there's a bunch of stuff installed from PyPI because unlike the other example I showed you, this one installed all dependencies of this RTDS action from PyPI. If I would have installed them before from CondaForge, it wouldn't look like this. Yeah. So you see, you have these ones, and these ones are green and blue. And if you use the X, I think the X is a option you have. Is X, lowercase x? Yeah. So this one means only the ones I have, the first level, so to speak, the ones I have explicitly listed in my TOML. If I don't say, it shows everything, dependencies of dependencies. Yeah. So pandas, PyTest, and Python itself installed from CondaForge, as you can see. So, by the way, the prefix dev people, they have their own CondaForge clone, so to speak. They have their own repository. It's one of the business models. You can buy a private one there, but they kind of also mirror CondaForge, so you can also install from there. That would also be a channel if you like. Yeah. So that's something you can install. You can also, what I did, I exported them to JSON. You can do something with JSON. You can work with it. Let's skip this for now because I played around with it. You can also use a tree. Yeah.
Can I get the Pixie list for my test environment without activating it via shell?
Yes, you can say Pixie. You can always say Pixie run. Let's make another directory here and another shell here. So you can always say Pixie run, and then you can say Pixie run. No, Pixie. What do you want? Pixie list. Pixie list, and Pixie list would do the same thing here without activating, because I'm in the directory now. To look personal directory would do the same thing, and it should also support environments. Yeah, -e. Yeah, you can also execute the same thing. So I want to have only E test, and I want only X. Yeah, so since the test environment depends on the default, they are also installed in test. It's not only test, because we have this, if you make yet another environment that doesn't depend on the default, it wouldn't show like this. So we can try to do this. So make another feature. Docs. And put in things. Docs, yeah. Dix docs. And I say things or MK docs or whatever. So I put things in. Talking, typing, having the microphone here. Thanks. And now, of course, I have to put another one. I can do the same thing here. Make a new environment. And I call this docs. And hopefully this everything works. Never do live demos. So docs. And now I solve docs in docs itself. And that should be different. So something like this, save it, and now do the same game again. But instead of test, I say docs, and now it should only show things because it don't depend on it. So you have to say pixie install first, I guess, otherwise it doesn't know. Why am I not in the right directory? Yeah. I modified a different TOML file. This is very common. They're all called the same. So now copy this whole stuff and copy to the right TOML file. So I'm in the wrong TOML file because it was still open, and they're all called TOML. And you see, I just modified the raw TOML file. So put this here, copy this from there to there, and then undo the other file. So because I have two TOML files open. Okay, now it's sorted. Good. So now if I say, give me this this one, then you see why does it show me the other ones? It should be only this environment. So the list seems to, because I say list only docs, and I say, yeah, it shouldn't show me pandas because pandas is not part of it. You see, I have a solve group docs, which shouldn't take the default into account. I'm surprised myself, so I learned something new because that's what I expected.
Can you exclude default, or is it maybe as it's default always in there? Because the PyTest is not in there anymore.
Yeah, you're correct. Maybe default, yeah. Since it's default is always in there. Yeah, but why doing this? Yeah, that's a good thing. Maybe, probably you can have to look.
Wait, so if you call solve groups docs, it'll create a new solve group, but it will still include default because default has special status, or it would ignore anything in default. Like what is the role of the solve group?
Yeah, of course. Since I list default here, I assume that is excluding it, but it shows it. So I'm surprised.
Is it still the correct file that you're looking at? Yeah. Like that being like solve group default being the default, you mean?
Exactly.
Yeah. That's what I was wondering.
Not even the default, but actually excluded. Like actually always.
Yeah.
Even if you put something else there.
But the test has the default, and the docs doesn't have the default, right?
I don't know if it the same.
Okay.
But the test is not there. So you can make enough, if you make enough environments, you can answer the other. Default might be special. This is the way. Was here, I listed explicitly
So then the idea of global is it like similar to like Conda base? Is it like just another isolated environment? Mhm. Mhm. Okay, so like, so basically, like, the idea is that you can use it for the whole. And then the commands in global will be ignored as soon as you're in a specific project. Yeah. Yeah. Okay. Yeah. Thanks.
You can use the Conda package, yeah. And you can do this as an example. I write a program that does something here, that does something, and then see I can build it. This will be built. This will be real, and I can make it task and build it. Say it will be built as a task. Real. That would be pretty easy.
One question about the wheels. So in this case, you are running this in an environment which is on your computer will have some compiler that didn't come from Pixie. Does it build, for example?
This is only Python. This is Python only. There's no compiler involved. The wheel is just a zip file where you set the Python source in a certain way with some information. That's what the wheel file essentially is. The same for conductor. So there's only
So for example, here you're not building many many Linux wheels and
Yes, they are all no architect, no architect. This is not none. So yes, this is pure Python, works for any operating system, any Python version under conditions specified.
okay, thank you.
Yes, we're running out of time and other talks. Yes. Thank you for the talk.
Hello. Yes. Can you hear me okay?
Does it work?
Yes. But it will be challenging to hold the microphone and do the things.
Yes. Yesterday I was holding the microphone when someone was talking and.
For 1.5 hours.
Not really. It was half an hour and we were two of us, so we were changing.
Yeah. Now I have 1.5 hours. But I don't do like live focus. It's mostly just live next.
Okay, so it will be easier.
Yeah.
That person was live coding all the time, so
Yes.
it was impossible to.
Live coding with one hand, that is.
I think I was present for that, and she held it in one hand, then she went to the other one, and then I think you showed up, and then you released. I don't
Get
know.
some water.
W tej sali nie. W sensie, to jest niestety problem wydziału.
Ja wiem, że kwestia mikrofonów to nie?
Czekaj, bo było rozwiązanie, ale ktoś do niego nalał wody.
Jak? Co?
Dostał mikrofon w szklance.
Aha, dobra.
Are you the host for this session as well, or you can do your own things?
There are no hosts for
Okay.
no chairs for like the.
Will you check the tech now and works?
We found the solution for the microphone.
And there is no, for this room, unfortunately not, and the venue doesn't have
I tested
like this. So one, two, two, two. One of them was expensive.
Okay.
Raz. I think this one, right?
I think.
Raz.
Aha, that was the
Yeah, the high-tech invention
Okay.
came up with. And it kind of worked for the first tutorial. I was listening to it online. If you can hear the speaker, and you could.
Okay.
So,
Nice. Are they being recorded or just streamed? Or
streamed, but then the recordings stay on YouTube. Is it okay or?
yeah, no, it's perfect.
Okay,
It's great.
yeah.
Because I did the same at EuroPython, but they did not have a recording. So.
For now, we do until the audio dies in the middle of the session, like yesterday. But this room is more stable apparently than that one.
Okay.
Yeah. And the second microphone, if people have any questions, you could force them to use the mic also for the question to get recorded.
not there. This one we will have to share.
Okay.
So people will rotate on that.
To jest i tak lepsze rozwiązanie, bo wczoraj trzymaliśmy mikrofon. Dosłownie staliśmy i trzymaliśmy, ktoś zaeksplodował.
Myślę, że nie wiem, jest to żeby Wydział Informatyki nie miał 3 mikrofonów krawatowych, które dobrze działają. W takim razie mówi thank you for your service, nie?
Tak, nie był to problem. Krótki wykład, więc...
Teraz gorzej, teraz jest 1,5 godziny.
No nie, 1,5 godziny to już bym się nie podjął. Ale jak siedzisz i masz na tej wysokości mikrofon, to jest ok.
No właśnie.
Bo to jest przy twarzy praktycznie.
Told the people outside that they're starting. So I think, yeah, people will be like forgetting.
I think by slamming the door we
Communicate. You started the wave. Yes. I'll give people 3 minutes to. So. Sorry. No, thanks. We'll share those. This,
Ten sit here if you want. Here or here.
don't use that row. Okay. Share. Next row. Hello? Yes. We are red on the microphone, but it seems to work. So welcome, everyone. Thanks for joining this tutorial. We'll talk about Python on very, very small devices. The course material are on this GitHub. This QR code will take you there. So we'll have a slide deck, which we'll go through. I encourage opening the live one in case we do need to make some small modifications. You'll instantly get the updates. And yeah, you can use it to follow along. You can also use it to skip ahead. If you find the stuff that we're talking about right now, it's a bit basic, then you can just jump forward. And also, it will be very useful to look back. Might need batteries. Okay, yes. So yeah, so please make sure that you've opened these slides so that you have them accessible. And then, yeah, so a little bit about me. Oh, sorry, there's some people still wanting the QR code. Go for it. So my name is Jon. I'm an electronics engineer originally. I did a master's later in machine learning engineering. And I run a company called Sound Sensing. We use sound and vibration sensors to analyze data from HVAC units, so ventilation, heating, and cooling in buildings, and we notify the operations team when there is something weird going on, mechanical or control issues. And we use Python throughout our entire stack, backend, of course, around machine learning, and also for prototyping new sensors. But yeah, the goal of this tutorial is that you as a software developer, be it like professional or hobbyist, probably most are more on the professional side here, can build simple IoT sensors using MicroPython. So goal is to, you probably know Python from before, and the goal is to kind of give you a new tool in your tool set so you can use Python to also do physical devices. Yeah, as I mentioned, the materials are all on GitHub. They're also linked on the the tutorial page for this session. So make sure that you have those. And what we will cover, I've split it up into 3 different sections. So in the start, we will be going through some basics, and we will run everything in a simulator called Wokwi, which is browser-based. So it means like zero setup, etc., which is nice to just get started. And then we'll have section 2, where we will be running on device. I have brought 5 kits with me, and we are like 3 groups of 5 roughly. So that means we'll need to iterate on that. But the goal is to get everyone up and running, to run a few examples on device, and maybe make some small tweaks to the examples, or something that you've tested in the simulator, and then you try it out on device. So the goal is to get everyone there. And section 3, it might be more of a bonus, I think, for this session. I did this tutorial at EuroPython, but we had 3 hours, and now we only have 1.5. So we'll see how it goes, but we might skip section 3, at least that. It might be something you can do if you want. So that's about running MicroPython on your PC, which is useful to have a local development environment, which is not dependent on the device. I use that a lot personally, but it's not something you need to get started. And I have also section 4 about so-called advanced topics. They're not necessarily difficult, but it's just like beyond the basics that you always kind of want to know about. So that's more self-study. So if you find that, if you maybe done something this before, or you find the basics too basic, you can jump to that and have a look at that. There's also throughout the entire slides a lot of links to external resources. There's a good community around MicroPython and a lot of good online resources. I try to collect them. It's hard to find these days. Google is getting worse and worse and worse. If you search for MicroPython and then something today, it will basically, without telling you, give you results about Python. So that's a challenge. And same LLMs are getting a little bit better though, so they're understanding a little bit more about MicroPython, but it's a little bit challenging just because it's niche and they think you mean the big Python. Yeah, in the section 1, which we'll go to soon, I'll talk about just what are microcontrollers, what's MicroPython, what is Wokwi, this tool, and we'll cover analog and digital GPIO, which is just basic reading and communication, concurrency using async IO, that's probably familiar, but it may be a bit surprising that you can do this on these small devices. Digital buses, they are common for communicating with sensors that are a little bit more advanced. It's very, very popular these days. So that's a key skill. And then on the internet side of IoT, we will have a session about talking to servers using HTTP client, so just like pushing something from a server or fetching something from a server, but also IoT networks using MQTT. That's a little bit more specialized towards this topic. Any questions about the overall agenda or structure, or any problems? Anyone managed to get the slides? Yes? Okay, that's good. Yeah, it will be okay on the mobile as well. Okay, then we will jump into it. So just like, what is a microcontroller? We will run Python on a microcontroller, but what is a microcontroller? So these days, a modern microcontroller is a complete programmable system on chip. So this is the actual microcontroller. This is what's called a breakout board, a development board. And these days, for a couple of dollars, you can get a couple of 100 megahertz CPU with a floating point unit and hardware, and with a few megabytes of RAM and flash. And this is a big step change over, say, like 10 years ago, where you would just have like maybe 10 to 100 kilobytes of RAM. And this, with the newer type of devices, it's much more realistic to actually run Python on it. And nowadays, you can treat these as like more like a small computer than a very specialized system, which is nice. So it will be familiar to you in Python, and you can do a lot of things without having to be crazy about optimizing or crazy about low-level programming. And they also have connectivity, a lot of these devices built in, so you'll often have Wi-Fi as well as Bluetooth low energy. And USB also is getting standard to have like native USB-C, so you can make USB-C devices that follow these like standards that you have, like emulate a keyboard or just a USB disk or this kind of stuff, which is also very convenient for making things that you can plug together with other things. The scale of electronics today is pretty mind-boggling. So there are now over 20 billion microcontrollers shipped every single year. So for every human on the planet, we're shipping almost like 5 microcontrollers each year. So this is growing. So we have a lot of them around, and they are basically used everywhere that you have electronics. So like a simple device like this will have at least one microcontroller, and probably maybe even a secondary thing that is programmable as well, so technically a microcontroller. Same with this kind of HDMI, everything you have around you, a charger, like a modern car, they say it's like now over 100 processing units that are connected together. So there's like anywhere you find electronics, you will find lots of microcontrollers. So it's a very useful skill. The focus of this talk, so it is used like everywhere, so we cannot learn about everything. We will focus on the software side. So we will be focusing on MicroPython, what's happening kind of inside the microcontroller. There will be not much learning or any learning about hardware. That's take us for granted almost. A little bit about how you communicate with sensors, analog, digital, and these buses, and then how you communicate using wireless communication with Wi-Fi and the things that you build on top. So like this allows you to build a lot of different things, typically IoT sensor systems, where you overall flow, you read sensors, you process the data somehow, and then you transmit or act on that data. But if you would add a little bit of motor control or something like that, then you could easily do robotics with the same tool set. There's a couple of slides at the advanced section about how to read higher data rate sensors like microphone and camera, which are also possible with this grade of device. It's a little bit more challenging, but possible. So if you're interested in that, you will find some section at the very, very end. Yes, so about MicroPython. MicroPython is an independent implementation of Python. It implements Python 3. It's somewhere between, depending on the feature, somewhere between Python 3.6 and 3.10. And it tries to be as compatible as possible, but there are some differences. It works for a large range of microcontroller devices, so, some 8 families, and then you can use on top of Zephyr, which is a Linux Foundation project, to target a lot of other hardware. It's a very mature platform by now. I wrote that it started in 2010. I think that is correct. It's over 10 years. People are shipping things into space with MicroPython. People are shipping medical devices with MicroPython. There's of course a lot of IoT, like more consumer grade things. So it's widely used and not just a hobbyist tool. I have one presentation from FOSDEM that goes a little bit more about MicroPython itself. Yeah, about compatibility. So it is Python. You will find the language and everything like that very, very familiar. Large degree of the standard library is available. Not everything is installed by default. So you might want to install some things from MicroPython lib. we'll cover how to do that later. There are some known incompatibilities. It's really hard to be compatible with everything, so there's a list of that online. There are some features that are not implemented, and you will find some lists there as well. A big thing is that the C API is different, which means that you will not find the same C-based libraries that you are used to. And that might be, depending on what you do, quite a lot of things. So you will not have pandas or numpy or these kind of things. But there are in many cases alternatives, and we'll maybe have a quick look at some of them. Yes. So yeah, and it will be very familiar to you in general as Python devs. Small scripts will work without mods, but if you have large programs that use a lot of external libraries, you will likely need to refactor that to use some other dependencies, basically. So it's not so much of a language thing, but more of a kind of the ecosystem is different. And it's important to note that this is not just for the fun of it. It's like a lot of the devices or the libraries that you're used to wouldn't meaningfully work in 1 megabyte of RAM. Like if you import NumPy is very efficient. You import it, it's just like 13 megabytes, but that's already 13 times too much. If you import something like scikit-learn and run like one estimator, that's like already 100 megabytes. So even if we had compatibility on the C-level API, it wouldn't meaningfully work. So one thing that is in addition, very important, that you don't have on the regular Python, but you have key library in MicroPython is the machine module. So this gives you access to the peripherals, as they're called, of the microcontroller. So that's the stuff that allows you to communicate with the outside world. And that is usually of high interest if you're doing a microcontroller. So if you're looking for how to like do something with the outside world, make sure to check the machine module. And they are relatively low level. And then for some things you will find like higher level APIs and libraries built on top of that. But yeah, that ships on the device. And then yeah, you use that to communicate with the outside world. So let's go over to the practical session. Any questions about the basics before we go here? Like,
can MicroPython be compiled?
Yeah, the question is MicroPython can be compiled?
Yeah, to reduce the memory use on the microcontroller?
Yes. So MicroPython is a interpreter, so that will run on the device and it runs completely standalone. And you can send it, or you can have on the file system Python files, but you can also have bytecode files. They have the extension .mpy, and they are compiled in a sense. They are more memory efficient, but it's not compiled to the level of machine code, right? So it cannot do like intense optimization throughout the graph, and that would not be possible. And then you would lose the dynamicism of Python. Yeah. I can repeat the question.
Thank you. Is it on?
Yes.
Okay. So since the code is not compiled and it's put inside the microcontroller, is there a limit in terms of size of the code that you have to run in the microcontroller?
Yes, there's always a limit. Even on your desktop, there is a limit, but
it's much higher, right, for a desktop?
Yes, so you can on these kind of devices that we're talking about here, you can fit somewhere between 10 or maybe closer to 100,000 lines of code in Python.
Okay.
Probably enough for
That's including
most projects.
Right, not just your own code. 10 to
No, your own code.
Okay, and dependencies?
Well, that's your own code as well. I mean, in this kind of perspective, on this kind of devices, everything that that goes onto the device is, and apart from the interpreter, I would consider it your code. That's your project somehow.
Okay, thanks.
So yeah, so there will be limits, but if you have a couple of megabytes of RAM and a couple of megabytes of flash, you will be able to go really, really far with that. Of course, if you're planning a crazy complicated project, you might want to plan that out. But for hobbyist or practical small projects, it's not really a concern. You can deal with it if in the rare case if it happens. Okay, any more questions, or we jump to the practicals? Yeah.
So one interesting use of MicroPython is PyScript. So PyScript uses Pyodide and runs in the browser with WebAssembly. And usually when you load the full CPython, that takes quite a bit of download and some few seconds to get it started, depends on your network connection. And then MicroPython is a viable alternative to do something. If you do something simple, it's all you need. Some people do it to have something like a starting splash screen, which loads quickly, and then later on, if they need pandas and all the stuff, they go to and load something more heavy. So there's a very interesting usage of MicroPython in the browser.
Yeah. It's not covered here, but it's a good point that MicroPython is now it's quite well supported with PyScript, Pyodide, all these web things. So yeah, because then it's under 1 megabyte, or well under 1 megabyte, versus CPython, which is well over 10 megabytes, so maybe 50 or 100 even, with dependencies. Okay, let's jump in. We will use the Wokwi tool. On the next slide, there's a link to an example. It's a microcontroller simulator, which simulates on the hardware level. So it supports both things like Arduino, but also MicroPython, and it runs the real MicroPython. It's not a special version or anything like that, so it's very compatible. I haven't tried like really crazy things like the inline assembler that MicroPython has set up, but I do expect that to work as well. So I'll go through the example a bit. So it supports also these external electronics things, so you can kind of wire it up, and that's what makes it interesting for this kind of teaching and testing, is that you can have a couple of peripheral modules. So when I've selected the devices that I brought here, I actually did make sure that they have they're the same as you will find in the simulator. And it supports simulating Wi-Fi connectivity. This is quite rare, but a very interesting feature for this. So you can have programs in there that will actually communicate online, and that works the same on the device. It's a very basic code editor, so this is not a fantastic development environment. If you're used to anything more than a text editor, you will find some things lacking, but it's great for getting started. It's possible to extend it with custom chips in C. I haven't tested that, but that's interesting if you want to like teach something else and you want to add some different kind of hardware. So I'll open the example, and I have my microphone stand. Yeah, if you're in Google Slides and you're in, I gave you guys comment rights, so you can comment in the thing if there is something missing or wrong, or if you want to add some more information. Please do add comments. That's great. But that means that you need to, in comment mode, you might need to click in to the cell and then to get the link. Just so you know. If you're in slideshow mode, then you can click the links directly. Just as a minor tip. So here's the Wokwi tool. Please, everyone, just open the example, and we'll go through it. I'll just give you a quick tour. You have your file tabs up here. There's this diagram, Jason, represents the hardware. We're not going to touch that much. There's a library manager. That's for Arduino, so we're not going to use that at all. If you want to add more files, you do it here. This is also where you would delete a file. So you actually need to focus on the file and then click here. It's a little bit surprising. But that's how you do it. I don't think you need to log in, and you can, I believe, save even if you're not logged in. But that means that you need to remember that URL, because otherwise it will just disappear into the ether. That's the basics here, but the most important button is this green one, the Start Simulation. You click that, and it starts the MicroPython program. So it will, start the kind of simulated hardware, it runs MicroPython, and then it runs this main Py. This one, we are now doing what we call digital I/O, or what's more generally often referred as general purpose I/O, GPIO, something term you'll find a lot. And we are instantiating a pin. This is represents a physical pin on the, well, actually on the microcontroller, but it's broken out to a board here. And this is pin 11, GP11. That is what we're using for the LED. And we have another pin, pin 18. That's maybe somewhere down here, here. And that goes to a button, to this red button. What happens when we push the red button? The LED stops blinking, because that's the logic of this program. So this is, a super simple MicroPython program. This is the classical structure. You import stuff, you do some setup. Often for small programs, you might have your pins, etc., as globals. It's fine. If you do a really complicated program, I would consider doing it a bit more structured, maybe having a class that captures this kind of stuff. But for small things, this is fine. And then you have, after initialization, you have a eternal loop. This is how most kind of IoT hardware type things work. There is, there might be something that limits the rate of the loop. We have a couple of sleeps here in at least one side of this loop. But yeah, it goes through this as fast as it can. Basically. This question? Okay. So yeah, so this is the classical blink with a little modification that we can keep the LED from blinking. So I encourage you to go in here, and we are now at almost 30 minutes. I will jump through like a few more modules, and then I'll give you some time for exercise playing around a little bit there. There's also an analog read. So then we are reading a continuous value, and it's being printed. So that's the important thing here as well. Like there's no proper debugger in MicroPython yet. There is some work being on, but so it's printf style debugging. It's the way to go, or logging. And it's all the tools will give you the print stream directly on your device. So here we can change this pot meter, and it does change the intensity of that LED. It's a little bit hard to see in the simulator. This is nicer in the real world. And this is using a DC module, which builds on top of the pin module. And PWM is pulse width modulation. That's how we get this intensity change on the LED, which is similar to what you would use to control a motor, etc. I will go a bit quickly on this. Yeah, do we want to do a little bit more? No, let's just go in the into the code. I have 2 suggested exercises, but you free to do whatever you want or find interesting in this thing. So one around analog, like instead of outputting continuous, just make it so that it's outputs or turn on the LED if value is below an alarm threshold. Or in this digital, just change to another button and LED. You see that you can modify this code and get it to do some simple things. If you click on red, it doesn't stop. Yes, sorry, if you hold the button. It is not a toggle logic, but that's a possible, change that you can make. Well, understandable. Yeah, so if you want a clicky button, you can implement it in software. Good. Question is, how do you find the number of the pins? In the simulator here, you can hover over them. So that's somewhat convenient. So you can Google Raspberry Pi Pico W pinout, and then it would give you more of an overview. This kind of device, it can do basically digital communication on any pin, and analog only on some. So that's a key thing then when you choose your layout. And also the bus, which we'll get to next, can only be done on some pins. So yeah, you really, it's a good point. You do want to have a pinout map available for your project. I think we will continue. There will be space for exercises later. I'll show you a couple more things so that you can kind of do a bit more interesting tasks. So with Python on the PC, you expect that you have a file system, and you have the same in MicroPython, which is not so typical on an embedded device. If you're Arduino and so on, then it's a lot of work to set up a file system. But here it comes standard and built in. It's usually a internal file system in the flash. Oh, it's exercise time. You can also connect an SD card, and you can have a much bigger file system. So you might just have a little less 100 kilobytes in this file system, or a couple of megabytes. And it uses the completely standard Python API. So I don't think I will show that here, but there's an example for that. Just logging to a CSV file. And this is already very useful. Basically, you have commercial products that are basically just like one sensor and temperature sensor, humidity, and it just stores data and then allows you to transfer it to your computer over USB, for example, when you're done. That's a logger. Very useful. There are some other libraries built on top. I've made the implementation for NumPy files, which is useful when you're dealing with more larger amounts of sensor data, because it's much more compact than CSV files. And there are also a time series database. I forgot to link that here. Things like that you can build on top of standard Python API. And this is, of course, also the key enabling part in order to be able to have split your code into multiple modules. So you can have different Py files that will be stored in the file system, and as well as package management, all built on file system. So package manager, it uses a separate package manager called MIP, so that it can, it's very compact. MIP can actually run directly on the device. So if you have internet wired up on your device, you can install things with the MIP module. or otherwise you can use MP Remote, which we'll show later in the PC section. That would then run on your PC, and then you would install to a connected device or USB. So there's not really any search on the MIP MicroPython lib, unfortunately, but there's a good list of packages on also MicroPython, and you will find also that many things are not in MicroPython lib, but are just spread over GitHub. So you can install directly from GitHub like this. And we have an example for that as well. Just run it because it's the first one with Wi-Fi, I think. Yeah, so here's a super simple code for that. In this section, connects to a Wi-Fi. In this case, a simulated Wi-Fi in the Walkway tool, but it will be the same on device. So this is showing that. Important is, of course, the Wi-Fi password, the Wi-Fi SSID and password. And here it's then in connecting, which takes a little bit of time, and then it's installing a package, just showing then. We didn't have OS path before. This was a test for that, and now we have it later. So, and because MicroPython is, like the devices that your MicroPython is, they're quite small, you probably will need a couple of more libraries, or you would want that in many projects, because we don't know what's relevant for everyone, and it's a small set that is included. On that, you can actually do help and then string modules, and it will show you the modules that are built in to your MicroPython build. So this can be useful to just see what you already have. But then you can use MIP to install more things. Super useful and not like really common in the embedded world, but the rest of the software world, package management is like a key feature. So it's super nice to have that. What I find to be a super cool feature in MicroPython is that you can have C modules, and they can be distributed as what's called a dynamic native module. That is a .mpy file, which actually has binary code, so machine-specific code inside. And that allows extending MicroPython in C, and you can install these as well at runtime with MIP. So, and this is an example from a library that I maintain called emlearn MicroPython, which is machine learning and digital signal processing modules for MicroPython. Right now, you have to manually specify the correct architecture when you do this. It's a little bit annoying, so I've made a RFC for MicroPython how to handle this a little bit nicer. Just know that. And yeah, when you run this, it would then download this, well, after you connect, download this basically a C module with a Python API, and here just a training of a linear regression model with some trivial data. But this allows to combine, same as on Python, like Big Python, a lot of the key libraries that we depend on are implemented in C for efficiency, be it either memory efficiency or execution time efficiency. And this allows to do the same for MicroPython, which then gives it the same superpowers that, yeah, you can, there's basically no limit. If Python is an interpreted language, you can pick and choose where you use what and to get the most out of these devices. Yeah, so that's just good to know. There's a little bit more about these C modules in advanced topics. And then a little bit about concurrency. So you have a question? Having the what? Yes, what's the reason for having the module installation happen at runtime? Well, it's mostly a convenience or developer experience feature, you could say. that allows you to not have to rebuild the firmware. The alternative would be that it's compiled into the MicroPython firmware that you would flash on device. So that would mean that you need a full C compiler toolchain specific to your platform that you've set up, which is painful still. And you would then need to actually flash the device, which means you need a programmer. And but you can do that as well, and it's still the most common way of distributing C modules. So you have to choose that.
Those are different things. You could have it. You could, but it's here. It seems like you're doing the installation while your firmware is running. Versus, I mean, you could still have the tool chain having to be installed.
Yes, I misunderstood your question.
On your server or wherever you're building the library.
Yes. So yeah, you're right. Installing during the execution of your program is abnormal. This is done in the examples to have a single runnable example. In WooQuey, there is no way I can simulate the device, but I cannot simulate the PC, which would typically be the one that would install onto the device ahead of time.
Okay. So typically you would have like a build script or an installation script that does this. It doesn't like run when you run your firmware.
Yes, exactly. So the typical would be that you would use, you would have a build script that would have where a couple of lines like np remote install this dependency, that dependency, and so on. I put that in like a shell script and run that once. And typically also copy a couple of your files. If you split your bigger program into like say 3-4 modules and then your main, you would also include that there. So yes, typically dependency installation is happening prior to the execution of the actual firmware. That's great.
That makes total sense. Okay, that explains it, and the fact that you're doing it for the example. I guess one more quick question: does MicroPython have a mechanism for secure firmware updates, like over the internet?
Yes, there are some things there. There are several projects. It's not really completely mainline, so you will typically find another project on GitHub, etc., that does it for your particular platform, like FreeSP32 or another one. And there's kind of two strategies. Either you make a MicroPython mechanism for that, which is what some people do, or the other way is that MicroPython is just a firmware that is built into your target. So you could use the platform provided tools, and you would basically switch out the entire. So you would do like, let's say, call it outside of MicroPython. So both approaches are doable, have been done, but it's not super smooth because there's variations. People do it differently and so on. So you'll find information online, but it's not like there's like a one standard way of doing it.
Okay, thanks.
Yeah, that's a good candidate for an advanced topic that I should add. Okay, we will go through this section and then we'll do a little bit of exercise, I think, or see our timing. Yeah, maybe I'll go through 2 more sections and then exercises. So concurrency. We have a device which has most of the time a single core, although these days you are getting dual core microcontrollers, and it does not have any operating system. So there is no preemptive scheduling, no processes. And there's a limited support for threading in MicroPython. There's a little bit, but it's quite limited. So the way to do multiple things concurrently is to use cooperative scheduling in some form or another. You can do this completely manually, or maybe you can use generators to help you do that in Python. That's nicer than completely manually. Or you can use async IO, which is my general recommendation, to just go for that rather quickly. So this example is pretty basic, but just shows you that, yeah, we have async IO, so you can use the features that you are used to there, at least the basics. We create multiple tasks. Here's just blinking LEDs at different rates. So there will be 3 instances of this blink function all running at the same time, or seemingly at the same time. And then we have these yield points from the await sleep. And the simulator doesn't show completely. Oh, actually, it will. This one, there is no synchronization of the phase. So even if there have this is kind of like a typical like drumming pattern. They actually it goes to the same, but they probably start a little bit differently. So it's not phase aligned. So yeah, it just shows you can do things concurrently with the primitives that you're used to. A key thing when you're doing cooperative scheduling is that if any task would block the loop, they will block every other instance as well. So it's really important to avoid time.sleep, because that will just halt the entire program there. And if you're doing a larger computation in machine learning DSP, that can happen, then you want to chunk that up so that the time between each yield is reasonable. You might want that in the milliseconds range, and this will determine the minimum kind of scheduling granularity. For many things, it doesn't. It's not a pain point, but just know that it's important to avoid blocking the loop. Yes. So yeah, we have async IO. That's very nice. There's a fantastic tutorial to async IO and asynchronous programming in MicroPython by Peter Hinch. It's really thorough, has a lot of very practical examples and also primitives built on top. So if you're doing anything non-trivial with async IO in MicroPython, it's a fantastic resource. I think we have a question. It's for the recording. We'll have a recording, and we are still streaming. We are live on the internet.
So when you say that there's limited support for threads, are you saying that there's support for threads in a single core, or there's limited support for threads in multiple cores?
Both, to my awareness. I think the primary use of the threading module right now is to put a separate thread on another core, and then you can have communication.
Well, because in normal Python, right, you're even when you have multiple threads, they're still limited to a single core.
Yes, the same. It says the same in MicroPython. Well, so sorry, you choose your kind of let's call it thread affinity or something like that when you instantiate it. So you can have multiple threads. I believe, I'm not entirely sure, but I think you can have multiple threads on the same core, but it won't effectively give you concurrency. It's just a way to maybe port some threaded code or something like that. And then, but you can, I've seen examples, you can create a thread on the other core. And now you can delegate work between them.
Okay, so then like you have, so there's like a threading model in like a multi-core threading model then that supports synchronizing and.
Yeah, there are some primitives around it. I haven't used it much, and in general you don't see it used much, so I don't really know how much I would lean into that. And it's also only available on some hardware ports, and of course only on some the multi-core, only on those that have multi-core.
Well, because both the PyPico and the ESP32 both are dual core.
Yes, at least some ESP32s. And then sometimes also the other core is sometimes dedicated to networking only, and it's like not a user programming programmed core.
Well, that just depends on your firmware, right?
Yes. So I don't remember how, for example, in ESP32, it's relatively common to do that, but I don't remember off the top of my head how MicroPython by default is set up for that. But yeah, so threading definitely an advanced topic for MicroPython. Yeah, you're encouraged to look into it. I don't really know the state of it, but you get really, really far with async IO. So yeah.
Thank you.
Let's just look a little bit Yeah, I think we will do this section as well. We need to compress a little bit because we don't have 3 hours. So I'll talk a little bit about bus, and then we will go exercises. So we saw how to read a analog sensor, or we were emulating an analog sensor with our pot meter. You could do the same with the light sensor that we have here. But a lot of modern sensors are connected over a digital bus. And there are multiple, but I2C is one of the most popular, or I squared C, you can also hear it called. This is an accelerometer that I also brought this here. It will allow you to tell you the axis of gravity, essentially, which allows you to tell your orientation and also how quickly you're rotating around with the gyro. So I2C is a digital bus, bus meaning that multiple devices will share the same physical data lines, and each of the devices has its own address. And then inside each device, you will have what's called a register map. At least this is the most common way of exposing a device over I2C. So what you want to do is you will want to be able to say, like, read something. So you would read from the device, which has address hex 42 at the address hex 3 to get some data. Oh, I think we're missing one parameter here. There should be another 3 to indicate reading 3 bytes. And then you can write a byte by doing the similar things. You need to specify the device as well as the address, and then the data in case of a write. So that's the basics of that. This picture has all the terminology. So now the standardized terminology is that the microcontroller is what's called the controller. That's the one that initiates communication, and each device is called a peripheral. Yeah, so if you want to communicate with this kind of device, you really need the data sheet and you need this register map. That's like the key thing. But thankfully, you don't need to worry about the protocol, like the way these are actually toggling the lines. That's all handled for you by the device and the MicroPython library. So you can do this high-level things here. And there are a few examples. There's one for the screen. We don't have screens with me, unfortunately. And there's one with the accelerometer. I just opened them. Yeah, so they are very simple in the main one. This is the accelerometer. And this is a common convention. So when you're doing something over I2C, the register map, etc., it can still be a bit manual, what you need to do to get your data out. So very often you put that kind of driver into a separate file and at least a separate class, so that the details of how to get that data out is encapsulated. So your main program doesn't have to care. So in this case, and this one is lacking a bit in terms of comments. It would be nice to have some comments here. This one is putting the device out of sleep mode. So then you would need to write to a particular address. And actually this one is not even clear. This is the same as write to mem with 100, like this address and that value. And then you get the values. So this is the data. You can get the raw values, and here are some parsing functions. So like to convert this, because the data itself, we only deal with bytes, but actually this is int 16 that is packed in, so 2 and 2 bytes go together, and that's what you see here. So that we're decoding this packet into a meaningful data structure, and here we're returning it as a Python dictionary, so that the outside program. And you see that, for example, the temperature, which is here, there's also you need to apply some conversion in order to go from a 16-bit value into a Celsius value, and the required conversion is also in the data sheet. But yeah, when you do this structure, then our program doesn't have to care. So it's we can just do get values, and here we are just logging it. And in the simulator, this is the accelerometer device, and we can emulate that. We would change the orientation basically with this, or we can pretend that this is now rotating with a constant 10 degrees per second rotation. This would be like very crazy. Or you can set the temperature just so that you can see the entire flow here. Yeah, the screen example is a little bit more close to useful in the sense that you can make things there on the screen. And here, just counting up. It's a little bit small. Just counting up. This is a small, very popular screen that you can control over I2C. And this you also find there's a bunch of code for actually how to do that. And this is typically where you would look for a third-party module. So if you have a particular device or you're considering buying a device, it's wise to search for libraries before you buy the device so that you know, like, can I probably just use some existing code, or will I need to write a driver myself? So you'll find quite a bunch of drivers are out there, and they're usually not so, for simple things, not so big, so it's not that crazy to make one, but you do need to build the skill of working with datasheet and a little bit of kind of reverse engineering or experimental engineering. So yeah, those are the two things. And then I've provided exercise suggestions on each of these slides. And also with async IO, with this low pass and installing libraries, etc., and also with file system. So I think we can spend like at least 5 minutes on that. So you just pick whatever you are interested in and just do something like that. Or if you want to do something different than the suggestions, that's also completely up to you. But probably want to keep it small, like 5 minutes. Okay, so our 5 minutes are up. We'll go through the next section and then get everyone onto the device, and then there will be more exercise time in between there. We have 30 minutes left. So yes, just so we talked about now reading sensors of different kinds and buses, analog, digital, but we haven't talked about how to communicate with the outside world. So there's a bunch of different ways of communicating. The popular ones are basically all supported in MicroPython. We will focus on the network with Wi-Fi, but just know that you find LoRa, cellular, Bluetooth Low Energy, etc. Available. I think Zigbee as well, but I haven't looked into that. So when you communicate with the server, you want to have a HTTP client. There's an example for that. First, we need to connect over Wi-Fi. Now it's put into a function to make it a little bit nicer. And then we want to be able to actually send a request. And we use there's support of the requests module, which gives a high-level interface to that. It doesn't support params, which is annoying. That's why we are here. It's not a param, but that's why you will often do that in the URL manually. And this example just connects to Wi-Fi, and it sends a topic to a service called NTFI, notify.sh. And that allows to send notifications. So in either picking up those notifications in the browser or also on your phone. Hopefully it will connect. I have a simulated Wi-Fi, so that should work every time. Or not. I guess they are running something in the background. So if there are problems with their server, I can't do much. I hope it will work second time. I can bring up the docs maybe in the meantime. Yeah, so it sends. Yeah, now it sent. Wait. Now it's sent. That was the notification from this example. Yeah, so it's a bit slow. Maybe we're hammering their server. So it sends on a particular topic, and yeah, if you guys run it now, you will also send on my topic if you don't change it. So you can write me something here if you want. And this is just a way you can just define a new topic. You just choose it randomly, and then you can send to that. And you can subscribe. It will ask you if you want notifications in the browser, and you can do the same on the phone. So it's just a convenient way to be able to do notifications. And it's an open source thing. You can host it yourself, or you can pay for a paid plan if you want a lot of features. And there's no, well, you can add authentication as well if you, I think, on the paid plan. Otherwise, you would just use a very obscure topic name and hope that no one else finds it. So yeah, that's just showing the communication. Use requests is very basic, or like very similar to what you're used to, which is a very good feature. There's also a link to a JSON storage API. Hello from Julian. That you can also use, so you can like put some data on the server and then retrieve it. That can be useful. These are a bit more advanced. There's some IoT platforms so you can store time series data, and they provide you tools to visualize the graph, etc. ThinkSport is open source. Blink is a proprietary service, but they both have like free and affordable plans. So that's HTTP. Basically works as you would expect. Not much magic. MQTT is a bit more different and might not be familiar to you guys. So in MQTT, you have a concept of topics, in a way similar to the notification idea, but you can have multiple devices publishing typically on their own topic, like sensor 1 on one and then sensor 2 on another. And then multiple subscribers can subscribe to the same topic or on a whole family of topics using, for example, a plus for just everything under sensor 1 in this case, or the hash to have everything under that tree. So if you wanted to store this data into a database, you would probably subscribe to like everything, and then just stuff that into a time series database, etc. But you could also have a device be a subscriber in the case that you would want to control it. So then you could send from a device, you could send like turn on this motor or change the configuration of the device, etc. So it allows two-way communication. That's convenient compared to HTTP, which is not great for two-way communication. There's also some IT-specific features. You can have like some last will, like if the device hasn't been seen, the server or the broker can send the device on its behalf, etc. So, and it's very compact. You can do binary data. It's very suited for IoT networks. So if you want to make something like non-trivial, consider going MQTT right away. The thing is, you will need a MQTT broker. So you dig a little bit more components into your system. But there are great open source brokers. Rabbit is one, and Mosquito is another one. And you can also do MQTT in the front end, so that one of the clients could be a front end, like a web application. And you can use, for example, MQTT.js. And then the broker will basically allow exposed MQTT semantics over WebSockets. So yeah, that's very useful to know. I think we've done, yeah. So I think we will actually jump straight to here, the next section, running on device, so that we get people started, and then you can do exercises also in the meantime. So to run on device, we'll need to connect via USB Type A. I have one adapter. If people have more adapters, maybe we can borrow them down here, because that's an often problem. We will need Python for this. So make sure you have Python installed. 3.10 or later is fine. You download this example repository. There's a couple of plans here you can copy if you want, or you can unzip from GitHub. And then you create a virtual environment. I've used pip. If you want to use UV, you probably know how to do it. And we need to install the MP remote tool. This is a tool that will allow us from our PC communicate to our device over USB. So this is like the primary kind of development tool. For most of the things, you can just do MP remote run or like copy and so on. Sometimes it cannot guess it will guess the port of your device, but sometimes it guesses wrongly. You have some serial port or something on the device. Then you do MP remote connect, name of that device, which is different for different platforms, and then your command. So just know that that can be a thing. You can get trouble with if you use VSL, you need to do USB pass-through. There's a UI tool. There's some docs for how to do that. And you probably inside VSL need to add your user to dialogue group. On Linux, you might need to add yourself to the dialogue group as well. Apart from that, we can try to jump straight to, you install MP remote in the environment, and then you run straight to running on device. But we have 5, so that means when you've set up the environment, install MP remote, head down here. It's a first come, first serve. So and we will just have to share. And then run like 1 or 2 devices, 1 or 2 examples, like be a little bit quick on the first round. And then once we made sure that everyone got it working, then we can do kind of round 2, and you can spend more time on the devices. Okay, we have it first. Yeah, now we can open the session. Yeah, it's not that much space actually. Let's do it like this. Do you have an Android device? No, iPhone? Yes, then I'm not sure. Someone found that there is an Android app that does allow you to program the devices. Just plug it in and it's called micro REPL, I think. don't know if there's a similar for either. There might be. There's server for MicroPython in the place in the, whatever the store is called, and maybe there will be a way.
Micro what?
MicroPython.
I mean, for Android, it is.
Oh, it is Android. Then it's called Micro Rental. Yeah. Yeah, and just shout out if you have problems setting up the environment or installing the package or anything like that. So I'll try to unblock you.
We're going to keep this stuff up on GitHub for a while.
Yes, forever.
There is a forever, sure.
Yeah, and so I'm expanding it a little bit. I improved it a little bit during this days. Okay, you get it running? Yes. Got control. Device. Yeah. Okay. Oh yeah, there's a missing copy actually in this section. I forgot to add that last time. And I will do it right away so that I don't. So here, yeah, we need to copy as well. I think it's here. And you, oh, I don't know what it's called. There's this. Yes. Well, we copy the. Sorry. We need to copy the dependency, and then the np remote run will actually do the copy itself into memory. So when we only need to do CP on this one. So yeah, it might have worked for others because maybe someone has done it beforehand. So, and important here on the copy statements, oh, sorry, first it needs to be CP for copy. You need to have the colon. This indicates the remote. So in this case, we're copying from locally and then to the remote on just the root of the remote, like in SSH. But yeah, if you forget that one, that's very easy to do because they're small and you drop the end of the line easily. Oh yeah, someone did comment it with a fix. Yes, I do have one. I'll just get the dong. Yeah, we can try to use the mic for questions. At least if they're common enough, let's see. Okay, we got 5 people running, so we get.
Okay, so my question is, if we have a large project with many files,
yeah,
is there like an automated way, like I have all this file, this is my project,
yeah,
upload everything directly, yeah, not having to manually copy one by one?
Yes, there's a recursive flag for CP, like normal copy -r, and you can copy all the files inside of a directory. So that will work, and it's wise to maybe structure your project so that it fits well. Yeah, there's a freeze. Yeah, okay, we have someone coming. Yeah, and we have another device ready, so we have space for one more person. Copy command is not working. Yes, that is critical. You have run into a bug. The bug has, yes, the bug has been fixed upstream. Question is how to get that fixed version. This was fixed in np remote, but it's not released yet. We'll have to do that. There is a way. I will try to show it. So that's annoying. We found it at the conference. We fixed it. No MP remote. There's a typo as well. No device found. We'll try to reproduce the bug and tell you how to fix it. I need a device here. Yeah, so it affects some devices, not all, because of like stuff. Yes, okay, I got it. That's nice, in a way. I will see, there might be two ways to fixing it. This is workarounds because the proper version hasn't actually been released. Actually, let's see if I can do the proper fix, which would be to do MicroPython. Because it's fixed in Git. So the tool is tools, MP remote. And then how to remember this. Pip install git plus this thing, right? And then add. No, we don't need add. How to do the, there's a way to do pip install from a subdirectory. Let's ask Claude. Probably knows. It's something like this. And actually my thing is wrong as well. It's something. Oh, is it correct? I don't know. I don't trust myself because people, unfortunately, will have to clone, and it will do a recursive clone, which is a bit slow. Or maybe I shouldn't give it my bad solution. How to install pip PyPI or git Python package from git when package is in subdirectory. Yeah, it's okay. It seems to agree with me. It might work. So yeah, there's a fix for that in Git, but I think there are two possible workarounds. So this only happens if the OS package has been installed. So I think we can remove it. Oh no, did not work. No, I broke it more. Yes, now I cannot even remove things from this device. I bricked the device. Now, so there's a one-liner. It's a really simple fix in this line. Oops. And which line 104? We need tuple inside the quote around that because it's more standard compliant now, the output of stat, but that broke the thing. Now I can't copy because I need to fix this device, but this should work. So there's like a one-liner fix there. So if you're affected, it will affect like, I think it's 3 out of 5 of these devices have this issue and the other one does not. Yeah. And I will try to resurrect this device. Huh? Yeah, in it will give you a long error, and there's an error on the line that has, in the exception. In MP remote transport, there will be a line with eval os stat, and then we need a tuple around this os stat tuple function call. Yes. Yeah. In the meantime, I will try to flash this device so that it's back to normal. We could also reflash the devices to fix it. You guys managed to fix it? Okay. Yeah, it will take a while, unfortunately. Did you manage to get it? What environment are you in?
Sorry, what's the version?
Which operating system?
So that's Debian 13?
Yes. So then you probably need to add yourself to the dialog group. So there's a couple of steps.
Okay.
There's a couple of slides about that. Not this one. This one.
Yeah, okay. Okay, cool. Thanks.
Yeah. Do you manage to get it fixed?
Yes.
Great. And you as well? Nice. Okay. So just run a couple of examples to get, and then we try to get the other people on board, and then when we have time, we can work more on it later. I think we have lunch after this, right? Yes. So basically, the devices will be free for use during lunch for sure, and I'm also here. Yeah, later. So you can, if you're interested, you can do that. Let's make sure everyone gets up and running with the tools.
How much are they?
Yeah, this is like 10 euros. You can really get started. You might want to spend a little bit more just to like get more. It's something that you are interested in, like a couple more sensors or maybe you want a motor or something like that. So, but it's very accessible in terms of price.
Why did you use the Raspberry Pi Pico instead of like an ESP32? I mean,
yeah, why I used. Yeah, why did I use Raspberry Pi Pico compared to ESP32 or related? It's because they have two nice features. One is that it's supported the Pico W in the Wokwi programming environment, so the simulator, so I could find the same version. So this is actually Pico W, that's supported. But if you buy a Pico, you probably should buy a Pico 2W. That's a much nicer device for the same price. And it's super easy to flash it because, so I have installed actually MicroPython for you. There's a couple of slides how you do it. And for this device, it's really simple. It shows up as a USB device, and you just copy the file across. So it's great for getting started. On ESP32, which is also a great device for MicroPython getting started, you need to install a flashing program. It's also in pip. ESP tool, exactly. So it's literally just a couple of more steps. So yeah, but ESP32 is just as good a choice. Actually, if you're doing something which might need more RAM, go for ESP32 right away, because they have like 8 megabytes of RAM by standard, whereas this one on the Pico 2 only has like half a megabyte. So that's a big difference.
So you say Pico 2W, that's the one you want to get.
That's the one you want to get. This is a Pico W, the number 1. So it's just older. Yeah, there's one available now, and I'll try to fix this one, and we have 2.
You didn't catch the nature of the bug, what that was all about. You said there's a bug in which code or
It's in the MP remote tool.
MP remote tool.
Yeah, it was. It's a regression like 2 weeks ago. If you've installed a particular package.
Okay, but if you were just to install it right now, the bug wouldn't be there. Not generally, but if you have a particular your installation.
Yeah, there's like one in the examples. There's the combination of 2 things breaks it right now. So we were very unlucky.
Oh well, let's see. Bugs happen.
Yes. Okay. Who here has not got it running on device yet? Well, you have a phone. Everyone else managed to. You still have trouble, but just to have an overview. He'll help you. Okay. Yeah, okay. Let's make sure to pick it up later. Okay, but am I correct to understand that everyone got it running on device? Yeah, you run a couple of examples. Okay, that's great, because that's all you need to have on your PC in order to communicate this, and you can program now. Well, anything. You run a couple of simple examples, but you could make that arbitrarily complex. You know how to copy files, install files, etc. So that's great. I have a couple of more things we go through. Oh, we have 2 minutes, so that's on the right on the mark. And then this will be available to play with in the lunch. I will grab lunch, and then I'll come back here. So if you're interested, yeah, just bring it back so we can, continue. There will not be a structured part. Of course, you don't have to do that. It's just open opportunity for you. Yes. Oh, yeah, just like a very basic thing. The main.py file is special in the sense that when MicroPython starts, it will look for the main.py file. And if there is such, it will start executing that. So that's how you would make your program be permanent on the device. Copy it to main.py. We will skip this part about running on PC. Can can help people with that if you want. Just the reason why you might want to do that is to be able to test things on your PC without the device connected. Since it's Python, you can make it very portable, and you can develop most of your code. You can use automated tests, write some tests, and I do that a lot. So I do 90% of my development on PC, and I just test a little bit on device. There's also a mocking library now, I think, here, that you can pretend that you have this machine module and these pins and so on. So you can write tests that also cover that. And then you can run these automated tests in CI, right? So you can treat this as a proper software engineering project, which I highly recommend. Yeah, and you can run the web server, etc., also on PC. Yeah, advanced topics. I'll just mention what's here. There's a little bit about installing on device. That's the thing I did for you guys beforehand on these. So that's like a reference from when you get your own device. It's also, of course, documented online. If you do get a device, I recommend either ESP32 or the Raspberry Pi Pico 2 W. If you want to look at how to make efficient code with MicroPython, there's some tools for that. JIT decorators, you can do inline assembly, C modules. There's slides about that. There's slides about ESP machine learning with the EMLearn MicroPython, which I maintain. It's a little bit of section about embedded Linux. So if you have a small embedded Linux device, CPython might be a bit big in terms of RAM. Then MicroPython is an attractive target. A couple of things to that. And there's some things that I plan to cover in the things that you can do in the future. There's not really slides for those. That's just markers for myself. I know many people have asked about IDE support and static type checking. So static type checking is well supported. There's a project called MicroPython stubs, which provide the stub files. So that's pretty easy to set up. And that also has some tips about IDE things. There are extensions for popular IDEs, VS Code, PyCharm, that give you kind of like this press play type experience. And that uses usually MP remote under the hood. I don't use that much. I can't tell so much about it, but it's available. And then, yeah, running MicroPython browser, as Mike pointed out, is possible. And yeah, there's that can also be useful. Yeah, so that's what you can find in the extra session. And then, yeah, you're encouraged to stay around if you're interested and just, make some small programs, or maybe you want to ask me some particular problem about if you have an ideas for projects, etc. So that's all we had. So thank you so much for coming. Great, and I think it is lunchtime as well. So. Thank you. It's great. Hope you have a new tool in your toolkit. Right now you can do physical things with Python as well. Well, the ABC is here. This is an analog sensor, so it's in light. Yeah. Right, yeah, so it might be unused there. It might be just left around copy the computer. Yeah. You could change the value and yes. And I believe that the analog example, which is the simulator, you can copy your display. I think I don't think the yeah, this accelerometer, gyro, and temperature, that's all inside this. This is an analog sensor, so the element is here. Like the resistor, this is an analog voltage.
Okay, so we are not really I mean, this file is just
yes. Yes. I think there's an ABC definition there for the thing, but it's not red. So you could the analog example in the simulator as code. Copy that. And then you'll find a library that works well with these kind of parts like this. Maybe it will be. What does that actually mean? You already have them. You've already spent more than $40 on electronics.
No, I'm retired. I don't. This is dinner.
Yes, dinner is what you spend the next $40 on.
Yeah, well, and maybe more. So you could just use like a Jupyter notebook and load in MicroPython, this MP remote, and then go directly to the device. And
yeah.
It's not particular about what kind of Python editor you use. And
No,
things
if
like
you
that.
use MP remote, it doesn't care where you got those files from.
Okay, and that's great. Yeah. Okay. If like I said, I've been using the ESP. I'm just playing around. I'm just hobbyist. Hobbyist in ESP32 and that Donnie program, and it works okay, but it's kind of a black box. I'm not really.
Yeah.
This is a little more. You've connected a lot of dots here, that sort of thing. I'm just looking at it on the phone, but I think I can email you if I have any questions, probably.
Yeah, or better to use the MicroPython Discord, and you can just add me there. But then then there are other people that can answer questions. Maybe other people can learn as well.
Yeah, one thing was this Walkme thing. I mean, kind of reading about that. I've never even heard of it.
Yeah,
that sort of thing. That looks pretty good. And I guess there's an API where you can develop. I think developing the circuit models and things like that.
Yes, there is.
Yeah. There's an API for that sort of thing. That looks kind of interesting, and that's. I had no idea any of this existed, and that's kind of curious. So.
Yeah.
Nice. I mean, would manufacturers include device model, like a SPICE model or something?
Oh yeah,
like
well, Walkme doesn't have the recognition yet, and it's basically like there's two people working on it.
Oli guy or something. I just noticed that.
But yeah, I think that would be a good model for them to try in the future to get that, because right now there's not that many modules, and it would be perfect if he could get the.
Yes, I do a lot of SPICE stuff. I mean, I'm a hardware guy.
Yeah,
I'm not really a soft. You've probably figured that out by now. But having a compatible tool for microcontrollers and things like that would be really nice. And there it is in Walkme. So
yes, I'm looking for. I will try to play with that, because there are sensors that I would like to, including teaching or projects, etc., that are not in there. So I would like to just try it out and see.
Yeah, if you've got a one-man operation or one-person operation, that's kind of. But if you can get a community where you like to have the API,
exactly.
Does this work in your acoustics work? So you do with construction or something like that. So this all fits in with that.
Yeah, a little bit. I mean, as a CTO, I have like a lot of responsibilities. I don't get so much time to spend on hardware and sensors. But when I do have that, and we're prototyping new sensors, then I use MicroPython often to do that, to record some data, see and check it out, and then prototype. And then when we get something that is looks ready for production, then actually our sensor manufacturer, they will do the kind of firmware for that, because it's hyper power optimized in C, etc. So, but I use MicroPython for the prototyping phase, which is super good.
Right. So when I get back home, I live in Malaysia, but when I get back to Malaysia, I should be able to use MP remote and be able to see the port on the on my device.
Yeah.
Is that your invention? MP
No,
remote?
this is all part of the standard MicroPython tools.
Okay, and it's been around for a bit.
Yes, there's like at least 3-4 years with that.
Okay.
There was another thing that was a bit more board specific before.
Okay, so that's really good work, John. Thanks for putting this on.
Thank you. Thank you for coming. just leave that. Sorry.